In this video, we are going to talk about how to complete the square of a binomial first, and that's going to lead us into the process of solving using completing the square. So if you have this binomial x squared plus bx, if you add the following number, b divided by 2 squared, okay, which is the square of half of the coefficient of x, then you end up with a perfect square trinomial, okay, where you have x squared plus bx plus the b divided by 2 squared. And remember, b is just a number, so these will actually just be numbers. You can write this as x plus b over 2, the whole quantity squared. So let's pretend that this is our x squared plus bx, where in this case b is 10. What I'm going to add to this binomial is 10 divided by 2 squared. So what I end up with is x squared plus 10x plus, well, 10 divided by 2 is 5. 5 squared is 25. Okay, plus 25. And this is a perfect square trinomial, which I can write as x plus 5, the whole quantity squared. And then remember, in our last video we talked about how we can actually solve problems that involve this whole quantity, something quantity squared. Okay. So the question on all of these is just what would we add to this to make it a perfect square trinomial? So you take your b value, you cut it in half, and then you square it. So negative 4 divided by 2 becomes negative 2. Negative 2 squared is 4. So to make this a perfect square trinomial, I would add 4. And then I would factor this as factored form. This would be x minus 2 squared. Always what goes in here is that b divided by 2. So negative 4 divided by 2 is negative 2. Okay. Again, I'm going to take my b divided by 2 and square it. So what I would be adding to this would be 121 divided by 4. As a factored polynomial or trinomial, I would write this as x plus my 11 halves, x plus 11 halves squared. Okay, and on this one, I would take my 5 halves, which is my b, and cut it in half, so I divide by 2, and then square it. So 5 halves divided by 2 becomes 5 halves times 1 half, which is 5 fourths. So I'm taking my 5 fourths, that's inside my parentheses, and I'm squaring it to get 25 over 16. But if I were going to write that as my perfect square trinomial, or factor that trinomial as my perfect square, what would I write that as? This would be the x and then plus my 5 fourths. Remember, it's that value before you square it. X plus 5 fourths in from here, and then that's the whole quantity squared. So now let's talk about how we use this to actually solve a quadratic equation. In order to solve this quadratic equation by completing the square, here's what I need to do. First things first, we need to make sure that this leading coefficient here is 1. Okay, we'll learn later how to deal with it when it's not 1, but we need to make sure it's 1. And then I'm going to move my c value to the other side of my equation. So then what I have is x squared plus my 10x, and that is going to equal 6. This is just like what we were looking at in the last couple, and I said, okay, what I'm looking for is my b value divided by 2, and then square it. Well, we did this one exactly. We said, okay, that is 10 divided by 2 is 5, 5 squared is 25, so I'm adding 25 here. Now this is an equation, if I add 25 to this side, I also have to add 25 to the other side of my equation. Well, now this side of my equation factors into x plus 5 squared. And the other side of my equation simplifies to 31. Well, this looks very similar to a problem we just worked out on the last section, which is I can take my plus or minus square root of both sides in order to solve. So I now have x plus 5, and that equals plus or minus square root 31. My final step to get my x by itself is to subtract the 5, and I'm going to leave that out in front. It becomes negative 5 plus or minus the square root of 31. Okay? Let's try a couple more here. First things first, move your c value to the other side. That's a 20. Okay. So I now have x squared minus 6x, and that equals negative 20. I'm going to take half of my b value and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So I'm going to add 9 to both sides. Okay, so what I end up with is x minus 3 squared, and that equals negative 11. I want to take the plus or minus square root of both sides, and then what I come up with is x minus 3 equals plus or minus square root of 11. I hope you remember that when we're dealing with complex numbers, square root of negative 11 becomes square root of negative 1 times the square root of 11. So that becomes plus or minus I square root 11. And then we need to add the 3 to get my x by itself. So I end up with x equals 3 plus or minus I times the square root of 11. Okay, one more. On this one, remember I first start by moving my 3 to the other side. Okay, so I have x squared minus 5x, and that equals a negative 3. Now I'm going to take half of my b value and square it. So this gives me, negative 5 halves squared gives me a positive 25 over 4. Okay, so then what I have now is x minus 5 halves, and that's the whole quantity squared. And then on the other side, well, this 25 fourths, this negative 3 is the same as negative 12 fourths. So 25 fourths minus 12 fourths gives me 13 fourths. I'm trying to make those 4s not look like 9s. Okay, now I can take my plus or minus square root of both sides. And what I get is x minus 5 halves equals plus or minus square root 13 over 4, which is the square root of 13 over the square root of 4. So that becomes plus or minus the square root of 13, and then outside of my parentheses, or outside of my radical, becomes 2, because I took the square root of that 4 and I made that a 2. My last step will be to add 5 halves to both sides. So what I end up with is x equals 5 halves plus or minus root 13 over 2. Since these are both with the same denominator, the book will likely rewrite these as x equals 5 plus or minus root 13 all over 2. Now, if they weren't the same fraction, if they weren't the same denominator, they would not add them this way, or you would have to find a common denominator in order to add them. I would accept either of these two answers. I don't necessarily have to have them in one like this, although you'll see as we go on, sometimes this makes it easier to simplify, because I could be looking for a common factor. Since square root of 13 does not simplify at all, I don't break this down any further to look for a common factor of 5, square root 13, and 2. Okay, that's all for this part. We'll see you in the next video.